Imagine you just spent a fortune building the ultimate state-of-the-art smart house. I mean, it has voice-activated everything, windows, that tint based on the sun's position, sleek solar roof,
Oh, yeah. Right.
like the absolute shiny future we were all promised. But then on your first night living there, you go to the kitchen, you turn the tap to get a glass of water, and nothing happens. Yeah,
Oh,
nothing. So you look under the sink and you realize the builder completely forgot to lay down the pipe connecting your house to the city's water main.
wow. Yes, so it's a beautiful, expensive shell, but it's completely disconnected from the fundamental infrastructure it needs to actually function in the real world.
Exactly. And that gap, that massive kind of invisible canyon between the sleek showroom promise and the gritty logistical reality is exactly what we're digging into today.
It's a huge topic.
It is. I mean, we all know the electric vehicle revolution is here. We see the cars everywhere. But what happens when millions of heavy battery-powered cars suddenly hit a 100-year-old electrical grid and a highway system that, frankly, simply weren't built for them?
Right.
So today for this deep dive, we are looking at some incredibly surprising data. We've got a 2023 electric vehicle charging strategy from a local UK town council, who are, by the way, panicking over their residential streetlights.
Yeah, that report is wild.
And we're pairing that with a tech industry report on mobile charging stations, plus a comprehensive market analysis of the U.S. roadside assistance industry stretching all the way to 2034. Because they are quietly preparing for a massive multi-billion-dollar spike in stranded drivers.
Because replacing a gas tank with a battery, it isn't just swapping out a part, it is fundamentally rewiring a century of deeply entrenched infrastructure. You're changing how energy is distributed, how vehicles degrade, and
Right.
honestly, how emergencies are handled on the side of the road.
Yeah. Okay, let's start at the very beginning of that chain. Because before a car can break down on the highway, someone has to actually buy it, park it, and, well, figure out how to plug it in.
Exactly.
And to really grasp the staggering scale of what it takes to rewire everyday life, let's look at that 2023 EV charging strategy from Wokingham Borough.
Yeah, so Wokingham is a really fascinating microcosm for this whole issue. It's a fairly typical, moderately populated area in the UK. And back in 2019, they declared a climate emergency.
Okay.
And they set a really hard goal to be completely carbon neutral by 2030. But when they crunched their emissions data, they found that transport accounts for a massive 31.2% of their total carbon footprint.
Wow, almost a third.
Right. And of those transport emissions, petrol and diesel cars make up an overwhelming 97%.
Jeez. So the mandate's pretty clear, right? The gas-powered cars just have to go.
They have to go.
But looking at the numbers they need to hit in this report, it feels almost impossible. I mean, in 2023, they had roughly 3,000 EVs registered in the borough, which was, what, about 3% of all cars?
Yeah, just about 3%.
But to hit that 2030 climate goal, they forecast they need 40,000 EVs on the road. That is a jump to 33% of all vehicles in just 7 years.
It's a staggering acceleration curve. And here is the physical reality of what that curve demands from the local government, right? To actually support those 40,000 cars, Wokingham projects, they need to install 1,992 new fast-charging sockets.
Wait, wow.
Yeah, those are your standard 7 to 22 kilowatt chargers, plus another 320 rapid chargers, which pull 50 kilowatts or more.
Okay, let's unpack this for a second. Because saying they need to install chargers makes it sound like, I don't know, plugging in a toaster.
Right, like you just buy an extension cord.
Yeah. But putting a 50-kilowatt rapid charger on a residential grid is like dropping a small energy-hungry factory onto a neighborhood block. I mean, if you just splice that into the existing neighborhood lines, the local substations would literally melt, wouldn't they?
Oh, absolutely.
You'd be browning out the street every time someone plugged in their SUV after work.
And that is the unseen hurdle. You can't just bolt a charger to a sidewalk. You have to trench through asphalt to lay heavy gauge copper wiring.
Right.
You have to upgrade the local transformers. You have to navigate zoning permits, deal with the disruption of closing streets for construction.
Traffic, yeah.
Exactly. And upgrade the municipal power backbone so that 85% of the town can actually charge their cars at 6:00 p.m. without crashing the grid.
And the human element here makes it even more complicated, I think. Because the Wokingham survey points out that 83% of drivers prefer to charge overnight at home.
Which makes total sense.
It does. But a huge portion of the population doesn't have a private driveway. They rely on street parking.
Which forces the local council to become essentially an energy provider.
Hmm.
Because if the town doesn't build out street-level charging, people living in apartments or terraced housing simply won't buy electric cars. The infrastructure has to precede the adoption.
But the cost of preceding that adoption is wild. The report mentions that Wokingham secured a specific government grant to tackle this residential charging issue. They got 173,500 pounds.
Right.
So hold on, let me get this straight.
Oh.
Given all the trenching and the copper and the transformers,
Mhm.
we just talked about how far does 173,500 pounds actually go?
Well, it bought them exactly 38 charge points.
38.
Just 38.
Across what, 18 residential locations? And they need over 1,700 total chargers by 2030. I mean, that math is terrifying for a local municipality. Where is all that money actually going?
Well, the hardware itself is only a fraction of the cost. The vast majority of that money is swallowed by the civil engineering required to physically alter the streetscape.
The labor.
Yeah, the labor, the specialized contractors, the safety compliance, and the grid connection fees charged by the national power companies just to tap into the main lines. So when you scale that 173,500 pounds up to the 1,700 chargers they ultimately need, you start to see the financial mountain local governments are standing at the bottom of.
With a price tag like that, it's no wonder people push back.
Yeah.
You know, I see this argument all the time, and the Wokingham report actually addresses it directly, the idea that EVs aren't actually better for the environment, so why are we spending millions tearing up our streets?
Right. You hear that a lot.
Yeah, the argument usually focuses on the batteries
Yeah.
and the massive environmental cost of mining lithium and cobalt. Does the math actually justify the infrastructure?
It is a vital question, and the Wokingham Strategy Report tackles it using life cycle emissions data. We have to look at the entire lifespan of the vehicle, not just the showroom day.
Right.
The data absolutely acknowledges the carbon debt of an EV because manufacturing those heavy battery packs, processing the raw minerals, it creates significant toxic emissions.
Right.
So on day one, an electric vehicle actually has a higher carbon footprint than a standard gas-powered car rolling off the line.
So they do start in a deeper environmental hole.
They do, yeah. But the math flips dramatically once the car hits the road. When you measure the entire life cycle, the manufacturing, a decade of driving, and the eventual end-of-life recycling the electric vehicle pulls far ahead.
Really?
Yeah, the data shows that, especially on a grid like the UK's, which is increasingly powered by wind and solar, a typical EV saves about 65% to 70% in greenhouse gas emissions compared to an internal combustion engine vehicle. So the payoff is undeniably there.
Okay, so the environmental logic holds up. But it brings us right back to our smart house analogy. We know the water is clean, but we still have to figure out how to lay the pipes fast enough.
Exactly.
And Wokingham is proving that we simply can't dig up the streets and upgrade the permanent grid fast enough to meet the demand.
The adoption of the vehicles is just outpacing the physical transformation of the cities.
Which creates a fascinating ripple effect. Because if the grid isn't ready, and millions of new EVs are hitting the road anyway, what happens when they leave the driveway?
Well, that's the multi-billion-dollar question.
Right. So we are looking at this comprehensive market analysis of the U.S. vehicle roadside assistance market, stretching from 2025 to 2034. And this industry is quietly bracing for absolute chaos.
Yeah, the roadside assistance market is booming in a way that directly correlates with EV adoption. I mean, the report projects the U.S. market alone will grow from $2.40 billion in 2025 to $3.69 billion by 2034.
And this is what really caught my eye. Because here's where it gets really interesting, We usually assume electric vehicles are incredibly low maintenance.
Right.
There's no oil to change, no spark plugs to foul, no timing belts to snap in half on the highway. I mean, they're essentially computers on wheels. So why is the rescue business exploding? Are we just trading transmission failures for a different kind of mechanical disaster?
We are seeing a complete shift in the failure points of everyday vehicles. The data from AAA paints a very clear, highly specific picture. When an EV driver calls for emergency roadside assistance, the number one issue isn't the complex battery system.
Okay.
It isn't a software glitch, it's flat tires.
Flat tires, really? Just
Yeah.
plain old rubber meeting the road.
Just flat tires.
Why is a high-tech EV chewing through tires so much faster than my old gas-powered sedan?
It comes down to the brutal physics of how these cars are built and how they drive. So first you have the mass. Electric vehicles weigh roughly 30% more than a comparable gas-powered car, entirely because of the dense, heavy battery packs slung across the floorboard.
Oh, right. So you have significantly more sheer downward pressure grinding the rubber into the asphalt every single second you're driving.
Exactly. That alone accelerates tread wear. But the real killer is how electric vehicles brake.
Okay, how's that?
They use regenerative braking systems. In a traditional car, when you take your foot off the gas, the car just coasts. And when you hit the brake pedal, physical pads squeeze a metal rotor to slow you down. But in an E, the moment you lift your foot off the accelerator, the electric motor instantly shifts into reverse. Yeah, it becomes a generator, capturing the kinetic energy of the car's forward momentum and shoving it back into the battery.
I've actually driven one, the one-pedal driving. The deceleration is incredibly aggressive. You barely have to touch the actual brake pedal.
Right, but think about the physics happening at the contact patch where the tire actually meets the road.
Hey.
The vehicle's massive heavy momentum is pushing forward, but the electric motor is instantly applying a massive reverse torque directly to the axle, trying to drag the tire backward. So you are essentially shearing the rubber tread in opposing directions every time you ease off the pedal.
Ouch. So the tires wear out far faster, the treads get thin, and when that heavy 5,000-pound vehicle hits a standard pothole, the tire just blows out.
Exactly. And the compounding problem here, which is what drives those roadside assistance numbers up, is that modern EVs almost never come with a spare tire.
Wait, never?
Almost never. Automakers ditch the spare to save weight and maximize the battery range. So a flat tire isn't just a minor inconvenience where you pull over, jack up the car, and bolt on a donut. A flat tire in an EV is a catastrophic failure that leaves you completely stranded. You absolutely have to call a tow truck.
Okay, so the physics of weight and torque explain the tire epidemic. But what about the classic EV anxiety? The dead battery. The Wokingham report mentioned range anxiety as a major barrier to adoption. Do people actually run out of juice on the highway?
They do, but surprisingly, the AAA data shows that running out of charge only makes up about 4% of all EV roadside calls.
Oh, that's really low.
It is relatively rare, but when a driver does drain the battery to zero, it creates a cascading logistical nightmare for the roadside assistance dispatcher.
Why is it so much worse? I mean, if my gas car dies, a truck pulls up, hooks the front axle, and drags me to a gas station in 10 minutes.
You cannot do that with an electric vehicle. Remember that regenerative braking system we just talked about?
Right.
The motors are directly permanently connected to the wheels. So if a tow truck driver lifts the front two wheels of an EV and tries to drag it with the back wheels rolling on the highway, it will severely damage those electric motors and the battery system. You can easily total an electric car just by towing it wrong.
Wow. So the standard hook and chain tow truck is just useless.
Completely useless. You almost always need a heavy-duty flatbed tow truck. And loading a dead EV onto a flatbed is a mechanical challenge in itself. The battery is completely dead, so you can't put the car in neutral. The parking brake is often electronically locked.
Oh, geez.
Yeah, so the tow operator has to use specialized skates under the tires just to winch this incredibly heavy, unresponsive brick up a steep steel ramp.
And once it's finally loaded, where do they even take it? Which I guess brings us right back to Wokingham's problem.
Precisely. If the local town hasn't built out its rapid charging grid yet, the tow truck driver is in big trouble. They can't just drop the car at the nearest gas station. They have to find an available rapid charger.
Right.
And if the nearest one is 10 miles away, and when they get there, another car is already plugged in for the next 40 minutes, or worse, the charger is broken.
Yeah.
The tow truck is stuck. The industry is facing a massive lack of mobile EV charging infrastructure. It is wildly unprofitable for a tow operator to spend 3 hours dealing with a single dead battery.
So what does this all mean? If the municipal grid can't upgrade fast enough to prevent range anxiety, and the towing industry is struggling to efficiently rescue the heavy cars that do die, there's a massive gap in the system.
Yeah.
Which is exactly where the tech sector and private industries step in to find a workaround, right?
Always. When public infrastructure lags behind technological adoption, private off-grid solutions inevitably emerge to bridge the gap.
And that brings us to the third piece of the puzzle. We're looking at a tech industry report on the newly launched second-generation Exos Hub.
Right, from Exos.
Yeah, Exos is a company that builds commercial electric vehicles, delivery trucks, step vans, the kinds of fleets that deliver our packages every day. And fleet managers can't wait 7 years for a city council to approve a trenching permit.
No, they have a business to run.
Exactly. They need to charge 24 trucks tonight so they can deliver packages tomorrow morning. if they can't plug a factory-sized load into their local warehouse wall, what are they supposed to do?
They look for a mobile, off-grid power bank, and the engineering inside this second-generation Exos hub is a perfect example of bypassing the grid bottleneck. What's fascinating here is they have managed to pack an integrated 390 kilowatt-hour battery into a trailer footprint that is only 16 feet long.
Okay, let me put 390 kilowatt hours into perspective. A really high-end home battery backup system like a Tesla Powerwall is about 13 or 14 kilowatt hours.
Right.
This trailer holds the equivalent of almost 30 home batteries.
Yeah.
But wait, if a fleet manager parks this giant 390 kilowatt battery in their lot and plugs it into their warehouse to fill it up, doesn't that just blow the local grid anyway? Aren't we back to the Wokingham problem?
That is where the integrated software and telematics come into play. It doesn't charge all at once. Think of the Exos hub like a massive water tower for electricity.
A water tower. Okay.
Yeah, a water tower slowly pumps water up through a relatively small pipe all night long. Then, when a fire breaks out and 5 fire trucks connect to the hydrant at the same time, the tower opens the floodgates and delivers massive instant pressure without bursting the city's small water mains.
Ah, okay. So the hub slowly sips power.
Exactly. The software inside the Exos hub constantly communicates with the local power grid. It monitors electricity prices and grid load in real time. So during the day, when factories are running and air conditioners are blasting, electricity is incredibly expensive and the grid is stressed. The hub does nothing. But at 2 a.m., when demand plummets and electricity is dirt cheap, the hub slowly sips power from a standard, low-voltage warehouse connection to fill its massive battery.
So it's basically storing cheap off-peak energy. And then when the delivery fleet rolls into the lot after a long shift, they don't plug into the warehouse wall, they plug into the hub.
And the hub dumps that stored energy into the trucks simultaneously. The report notes this new generation has actually increased its charger output to 40 kilowatts. And you mentioned the specs earlier. The report says the hub is outfitted with 5 CCS1 charge heads. CCS1 is simply the standard commercial fast charging plug used in North America.
Meaning, this single 16-foot trailer can physically plug into and fast charge 5 different delivery trucks at the exact same time.
And it does it in about 5 hours. It completely isolates the fleet from the limitations of the local grid. If we connect this to the bigger picture, the business avoids paying exorbitant peak hour electricity rates. They don't have to hire contractors to dig up their parking lot. And because it's essentially a trailer on wheels, if their warehouse lease expires next year, they just hitch it to a truck and take their entire charging infrastructure to the new building.
Wow. It is the ultimate stopgap. It's a completely self-contained workaround while the rest of the world scrambles to lay down the permanent wiring. And taking a step back, this is why these 3 sources are so fascinating when you look at them together. You know, whether you are actively shopping for an electric vehicle, or you just ordered a package online, or you're just sharing the highway during your morning commute, there is an incredibly complex, largely invisible ecosystem being built around you in real time.
It is happening right under our feet. I mean, the municipal debates over street trenching, the chemical engineering of heavier tire rubber to handle the torque, the deployment of giant mobile water towers of electricity in industrial parks. It is a massive, frantic effort to make that quiet, smooth EV ride actually sustainable.
But as we wrap up this deep dive, there is one final detail buried in that U.S. roadside assistance report that we have to talk about. And honestly, it fundamentally changes how we think about a vehicle breaking down.
Yes, this raises an important question. The report brings up a critical point about the vulnerability of a fully digitized transportation grid. We have spent this whole time talking about physical failure.
Right, the tires, the grids.
Yeah, heavy batteries ruining tires, the lack of copper wire in the ground, the mechanical struggle of loading a flatbed. But the roadside assistance industry is identifying a completely new, rapidly escalating threat that has absolutely nothing to do with mechanics.
Okay.
Cybersecurity.
Cybersecurity for a tow truck. How does that even work?
You have to look at how modern dispatching operates today. It is no longer a dispatcher sitting in a garage with a landline and a two-way CB radio. Modern electric vehicles are incredibly advanced rolling computer networks. And the roadside assistance dispatch systems are entirely cloud-based, relying heavily on IoT, the Internet of Things.
So all the devices are constantly talking to each other.
Exactly. When a modern EV suffers a critical failure, say the battery management software crashes on the highway, the car often automatically diagnoses itself.
Oh, wow.
Yeah, it instantly transmits its internal error codes, its exact GPS coordinates, and the driver's profile to a central cloud server. An algorithm in the cloud processes that data and automatically pings the iPad of the nearest, properly equipped tow truck operator to go rescue them.
Which sounds incredibly efficient and futuristic. Until, I'm guessing, someone with a laptop decides to intervene in that digital handshake.
And that is exactly what the industry is warning about. As the entire rescue infrastructure becomes reliant on cloud networks and connected sensors, the surface area for hackers expands massively. A bad actor could theoretically intercept the data stream from stranded vehicles.
Just intercept it.
Yeah. They could scramble the GPS dispatch routes, sending tow trucks to the wrong side of the city. Or worse, they could deploy ransomware to completely freeze the dispatch software that the tow companies rely on to operate.
So imagine you're driving home in the year 2034. You hear a pop, and your tire blows out because of the regenerative braking stress we talked about. You pull over to the shoulder, you don't have a spare, you aren't worried about the battery, you aren't worried about finding a charging station, but your rescue truck never arrives.
Because your biggest threat isn't a mechanical failure on the highway.
It's a digital hostage situation. A hacker has locked the dispatch server, and the tow truck literally cannot receive your GPS coordinates until the company pays a Bitcoin ransom.
It adds an entirely new invisible layer of vulnerability to everyday life. We are rushing to build the physical plumbing to support these vehicles, but securing the digital infrastructure that manages all those pipes that might end up being the far greater challenge.
It really makes you appreciate the sheer complexity of dragging society into the future, We all wanted the shiny, futuristic smart house with the solar roof. We just had no idea how much it was going to cost to lay the pipes, how fast it would chew through our tires, or that someone could digitally hack the plumbing while we were stranded on the side of the road.
The showroom is beautiful, but the highway is a very, very complicated place.
It really is. Well, thank you for joining us for this deep dive into the electric transition. Keep an eye out for those heavy vehicles, check your tire tread, and we will catch you on the next one.